Alright, today I'm going to start with chapter 2 about functions. So after reviewing chapter 1, mainly intermediate algebra stuff, now we're still reviewing some of the intermediate algebra, we're getting into college algebra stuff. So section 2.1, what is a function? So we're going to talk a little bit about functions, their domain, their range, some piecewise defined functions, and so on. Let's first recall what a function is. A function, in case you forgot, is a set of ordered pairs, points or ordered pairs, an x and a y, for which each x value is paired with exactly one y value. This doesn't say each y value is paired with exactly one x. It says each x is paired with exactly one y. So a y value may be paired with no x value, with one x value, or with million x values. But every x value has to be paired with only one y. No x value in a function can be paired with two or more y values. Okay? A function notation, the letters we use for functions, we use f, g, and h are the three main letters that we use for function, although sometimes we use something else like I or whatever. X is called the independent variable and y is the dependent variable. Okay. I'm gonna keep messing with this until I get it perfect. Okay. So now let's see some definitions. Some examples, sorry. So if f is a set of ordered pairs 1, 2, 2, 3, 3, 2, this would be a function since no x value is repeating. If you look at g, which is 1, 2, 1, 3, 2, 5, 6, 11. This is obviously not a function because 1 is got two different relationships, which is not a function. All what this is called a relation or a mapping, but it's not a function. Okay, evaluating functions. So for example, f of x equals x squared plus 2x. This is pretty straightforward stuff. So if we're given that, how do we find, say, f of 0? 0 squared plus 2 times 0. What's f of a? It's a squared plus 2a. You just plug the a in there. And what is, say, f of negative x? You plug the negative x in there, so you're going to square negative x and then 2 times negative x. So anything you put in the parentheses is going to overtake x. When you square a negative, it's positive. 2 times negative x is minus 2x. Okay, number 30, page 156. Page 156. F of x equals absolute value of x over x. What's f of negative 2? Well, when we plug a negative 2 in there, we get 2 over negative 2, which is negative 1. And f of 2, or number 2, is absolute value of 2 over 2, which is 2 over 2, which is 1. So now we know what a function is. What's the domain of a function? Again, this is all review. Domain is the set of all real valued x. So it has to be a real number for which y is defined and a real number. So any x will be in the domain of a function if you plug that that value of x in the equation, you can come up with a y value. Okay, if you cannot come up with a y value, then that x value is not in the domain. Range, domain is your x value, range is your y value. So range of a function is the set of all real valued y that correspond to some x from the domain. So a y value will be in the range as long as it's paired with an x value from the domain. If you cannot pair the y value with an x value, then it's not in the range. It's what we call in the codomain. Okay, so to be in the range, a y value must be paired with an x value from the domain. So let's look at 52, page 157. F of x equals 5x squared plus 4. We want the domain and range. While domain obviously are real numbers. Why is that? Because whether you plug in a 0, a 1, 10 millions, or -1, -2, -10 millions, you square it, times it by 5 plus 4, you're gonna get a y value. So any x value, when you plug in, it's gonna give you a y value, so that's why it's all real numbers. Range, now if you look at the range, your y value, this is y. Look, what this says, of course, if you graph it, you have a grapher, you're gonna see that 5x squared plus 4 is gonna look like this. And you can see the range, the smallest y value there is 4, so 4 or higher, so it's 4 to infinity. Or you could use common sense. Why is this? You know, x squared is always greater or equal to 0. If you times it by 5, it's still gonna be greater or equal to 0. If you add a 4 to both sides, this is your y is greater or equal to 4, and that shows on the graph, which is the range. You can do it any way you want. Now 56, page 157, usually it's not easy to find the range from the equation, although for some of them it is. But, okay, usually we graph the function to find the range. So 56, as you can see, they're only asking about domain because it's not easy to find the range from the equation. So what's the domain of f of x equals 1 over 3x minus 6? And that's page 157 in case you don't know where I'm at. Okay, so domain, now you can see we have a fraction. In a fraction, the denominator cannot be 0, because if it's a 0, then the y value is undefined. Okay, so if you start by setting this equal 0, the value that's going to give you 0 here is 2. So x equal 2 is not in the domain. Why is not? Because if you plug in a 2, 3 times 2 is 6, 6 minus 6 is 0, 1 over 0 is undefined. Remember, to be in the domain, x has to be paired with a y value. 2 cannot be paired with any y values. 2 is not in the domain, everything else is. So the domain is all real numbers except 2. And that's how we write our all real numbers except 2. Another example, what's the domain of f of x equals square root of x minus 2? Since x minus 2 is under the square root, to get a y value, x minus 2 has to be greater or equal to 0. So the domain is 2 to infinity. If you put a 1, you're going to get an imaginary y value. Remember, domain and range have to be real valued. If you put a 1.5, you're going to get a negative value. Anything 2 or over, it's going to give you a y value. And if you have g of x, which is cube root instead of square root, cube root, x plus 3 does not have to be positive, because if you do cube root of a negative number, you get a negative number. Like cube root of negative 8 is negative 2. So when it's a cube root, it's always all real numbers. Okay? Alright. Finally, we're going to talk about piecewise, no, 2 more things actually. The piecewise defined functions and difference quotient. So let's talk about piecewise defined functions. They are functions that have different outputs. Remember, an output is a y value for different inputs. That's your x values. For example, f of x equals, you'll get a y value of 1 if x is greater or equal to 0, and it's a negative 1 if x is less than 0. This is a piecewise defined function. If you graph it, you'll see what I'm talking about. It's going to be y equals 1 if x is greater. This is 0 or more for x, so y is going to be 1. And then it's negative 1 if it's less than 0. You get a graph like this. So let's look at page 156, number 34. Page 156, number 34. We're given a piecewise defined function, f of x equals 3x if x is less than 0, x plus 1 if x is between 0 and 2, and x minus 1 squared if x is greater than 2. Find f of negative 5. Now, which equation do I use? 3x, x plus 1, or x minus 1 squared? It really depends on your x value. This is your x value. If x is less than 0, you use this. If x is between 0 and 2, you use x plus 1. If it's greater than 2, you use x minus 1 squared. Since x is negative 5, it's going to fit into this. So f of negative 5 is 3 times negative 5, which is negative 15. For number 2, f of 1. Again, 1 is not less than 0, so we cannot use this. 1 is between 0 and 2, so we can use that. 1 plus 1, which is 2. And f of 5. Again, 5 is not less than 0. 5 is not between 0 and 2, but 5 is greater than 2, so it's 5 minus 1 squared, which is 4 squared, which is 16. Okay, finally, the difference quotient, which is basically the slope of a line, if it's a line, or slope of a curve. The difference quotient, which is similar to what we call the slope. So for example, if you have a curve, not necessarily a line, you have a plus h, where h is any letter, small letter. This is f of a. This is f of a plus h. This is y equals f of x. Remember, the slope is y2 minus y1 over x2 minus x1. Same thing. So f of a plus h minus f of a over, this is h, because a plus h minus a is h. That's called the difference quotient. So let's see an example about that. This is, by the way, extremely important in calculus. If you're planning on getting to calc, you really need to understand this, among other things. Find the difference quotient, f of a plus h minus f of a over h. Well, if you start with this, you're going to plug a plus h in there. So you're going to get a plus h squared plus 1. A plus h squared plus 1. That takes care of f of a plus h minus f of a is a squared plus 1. But because you have a negative, it has to be in parentheses all over h. When you're doing the difference quotient, you are not done until this h at the bottom is cancelled out. Once you cancel this h out, then you're done. So we gotta do some work. We're gonna FOIL that. A plus h squared is a plus h times a plus h, which is a times a is a squared. A times h is ha, and then ha again. And then h times h is h squared. That gives me a squared plus 2ha plus h squared. So this is that. Plus 1 is brought down. And then distribute the negative, minus a squared minus 1. That cancels that out. That cancels that out. And I would have 2ha plus h squared over h. To cancel out the h at the bottom, I gotta factor out an h from the top. And that's gonna be the difference quotient, which is 2a plus h. Okay, let's do one more. couple more actually. F of x equals 2 over x minus 1. What's f of a plus h minus f of a all over h? Same question. So we're going to take this and plug it in there. So we get 2 over a plus h minus 1. We're going to take the a and plug it in there. 2 over a minus 1 over h. This is a complex fraction. We're going to get rid of the secondary fractions. So we're going to times the top and the bottom by the LCD, which is a plus h minus 1 times a minus 1 over 1. Same thing here, a plus h minus 1 times a minus 1 over 1. When we distribute that, it's going to cancel out a plus h minus 1. So you get 2 times a minus 1, which is 2a minus 2. Minus a minus 1 cancels out, so you distribute the negative 2, so you get negative 2a minus 2h plus 2 all over all that. The 2a's cancel out, the 2's cancel out, negative 2h. Remember when we're done, when this h at the bottom is crossed out, we're ready to do that. So we get negative 2 over a plus h minus 1, a minus 1. Okay, 44, page 157. You know, I'm doing a few of these because this is very important, especially if you're going to go to calc. Again, find f of a plus h minus f of a over h. So we're going to take this and plug it in. So a plus h squared, don't forget there's a 3 up front, plus 2 minus f of a, which is 3a squared plus 2 all over h. We already foiled a squared plus a plus h squared, which is a squared plus 2ah plus h squared. So let's put that in here, a squared plus 2ah plus h squared. Don't forget the 3 up front. And then distribute the negative, minus 3a squared minus 2 over h. Distribute the 3. 3a squared plus 6ah plus 3h squared. 2's cancel out, minus 3a squared. Now we can factor out an h as always to get rid of the bottom h. And your answer is 6a plus 3h. 6a plus 3h. Okay, I want to do one more. 86, page 158. We're given the piecewise defined function. C of x is x plus 15 if x is less than 100, and it's x if x is greater or equal to 100. Part A, what's C of 75? Well, 75 is less than 100, so we plug it in there. 75 plus 15 is 90. What's C of 90? 90 is less than 100, so 90 plus 15 is 105. C of 105. 105 is greater than 100, so it's going to be 105. Well, x is 105. What do your answers in part A represent? So if you look at 86, what do your answers in part A? You remember, this is C of x is the cost as the total price of the book. So I want you to answer that, okay? It's an easy answer. And that's it.